Hello guys, welcome back to Data Forge by Piyush. So today we are going to learn less talk but very important window function. Those are lead and lag. So in our last videos we already have learned about row number, rank and dense rank, and we have seen the difference between all of these three window functions as well. So we use this below data frame in our last videos. This is the student marks data frame where we have list of students and their marks achieved in the final examination in mathematics and English. So for one school which has these many classes, first, second, third, fourth and fifth, and these many students are already learning there and studying, and they have secured these many marks. Based on their marks achieved in the examination in both the subject, we calculated the percentage for each student. So this is the percentage for each student out of 100. This percentage calculation we already have learned in our previous video. So I'm not going to deep dive into this percent calculation part in today's session. So we will move ahead on this. So this is the percentage part calculation. And based on this percentage calculations, we have learned how to get the who is the topper or who is the last rank holder of the class, or a second rank holder or third rank holder based on their percentage achieved or secured by them in the examination. So this is the data frame and this is the syntax and the code for getting the ranking for each student in the examination. We all have covered this everything in our past videos. So again, I'm not going to deep dive into this part again. This is what you can see. See, this is a list of students, their total percentage and their rank in their own class. Own class means, see, this is the first rank holder in the first class. Now in the second class, this is Adya. Likewise for third, fourth and fifth class. So this is how you can get the rank of each student in their own class. Okay. So this was all what we have covered and learned in our last videos. So today what we are going to learn is that is lead and lag. Now before moving ahead of this, let's understand why they are actually required or why we actually need them. So you can see, if we just take the data set of first class, there are 5 students. There are 5 students. For them, one is first rank, second rank, third, fourth and fifth rank holder. You can see first rank holder has 91 marks or 91 total percentage, while the second one is 86.5, third is 75 and likewise the last one is at 71. We can see all of this in the data frame. Okay. Now the question comes, although we have decided what is the ranking position for each student. Okay. But we don't know what is the difference between second and the first rank holder student, or the fourth or fifth rank student. Hope you are getting what we are going to extract today, what we are going to calculate today. You know you are at first position, your friend is at second position, but you don't know what is the difference, what is this difference between both of you. It's a 5%, 7%, 10% or what? Then how we are going to know about this? To know about the difference of difference between marks, difference between price or any other data set if we talk about, we need data set side by side, right? How we need this data set side by side means, if 91 is written here, your 86.5 should be at this place. Then you can perform the arithmetic operation over this data frame to get the difference between marks of two students, right? So this is what we are going to learn today, how to get the difference between marks of two students. But before that, see, Calculating the difference we already have learned in arithmetic series. We can just have it total percent minus or next percent or next student percent in all, right? So I'm not going to again define it. But before that, we need the percent of next student or second rank holder or the third rank holder, right? This is what we are going to learn today, and how we are going to extract that thing that we are going to calculate, and that is possible with the help of your lead and lag window function. So let's go ahead and try to use that lead and lag function and try to resolve this kind of scenarios. And this is almost all the time this kind of question comes in the interview, where you need to calculate the difference, addition, or compare the two values while in the original data set they are on a row wise and you need to put them in a column wise. So this kind of questions always comes. Focus it here and try to learn and resolve all your doubts in this series or in this videos only. Let's go ahead and write the syntax first for that. Lead and lag window function. Both are different. So let me start with the lag window function. Then we will see the lead function as well. Okay. So what is this lag function? Lag is what? See, this is 91, this is 86.5. And we want to calculate the difference between these 91 and 86.5. You know, if you want to calculate the difference like 91 minus 86.5, then you should have 86.5 here. That means what is this 86.5? This is after your 91. That means after means that 86.5 is leading your 91 in this sequence. Okay. Then if you want to bring your data which is after your data set or after your row which is actually leading you, then you need to use the lead window function. Okay. And if you want to bring 91 for this second row where the original percentage is 86.5 and you want to bring 91 here on this column, then you need to use lag window function. Lag, why? Because the 91 digit is lagging 86.5, that is behind it, and we need to bring backside data to front side. We need to use lag window function. And if we want to put front side data into back side, then we need to use lead function, which is so your data or your field which is leading you or leading your original data set, you need to use lead. If that is lagging, use lag. Let me first write, then you will understand in a better way. I'm going to copy this same syntax again, because in all of your window function syntax wise it is exactly same. Only the thing is going to change is one keyword. So what is that keyword? Instead of this row number, I am going to use this lead. And one more thing, here you need to bring what you actually want to call that column. So which column I am going to use it, that is total percent. Okay. And this new data set I am going to give the name as df underscore lead. Df lead where next student. I'm going to execute this command and let's see the result. This is the result available with us. You can see this is what we actually expected, right? This is the student 1, Myra, which has 91 marks, and the second student, which is Anya, is having 86.5. So what we have done is we have bring 86.5 to first column. What we have done is the second row data we have bring into first column also. This you can see 75 third row in a second row. fourth row, in a third row. We have bring these numbers like this. Now we can actually perform the arithmetic operation of minus, subtraction, to get the difference between students which are immediate leading them, immediate after them. Okay. Now let me calculate the difference between two students using this data frame, which is DF lead. So DF LD is equal to DF LD dot select student name and their total percentage. Along with that, what we are going to get is next student minus total percentage, because this is exactly what we want, right? If next student minus total percentage we do, next student marks is lesser, then it can give you the data in a negative format. So what I'm going to do is I'm just trying to subtract the total percentage minus next student, vice versa, reverse. I'm just going to do the reverse of this. Reverse next student. Okay, and I'm going to delete it from here. Quotation marks, and now I need to display this df underscore ld. So this is the result data set we have received it. We can see this is the Myra who secured 91, is leading or is has 4.5 marks more than Anya. Okay. This is Anya marks 86.5 while Myra is 91, and 91 is how much extra? That is 4.5. So 4.5 marks Myra has more than this Anya. Likewise, Anya and Arav, if we compare, Anya has 11.5 marks more than this Arav, and Arav has 3 marks only more than this Vihan, and Vihan has only 1 marks more than Kabir. But beside Kabir, you can see this is null. Why null? Because after Kabir, you can say after Kabir, there is no student in the class 1. That is, he is the last or the lowest marks achiever in the class. There is no comparison between him and lower marks students achiever in his class. You can see this is the result data set. This is how it looks. This is what actually we wanted, this kind of column. For that, we need to onboard this next student column. And how this column can be onboarded? Using this data frame, using this lead window function command. Now let me quickly execute this lag window function as well, which is going to give you the similar kind of result data set, but instead of this leading data, it is going to give you the lagging data from your rows. Let me not waste the time and calculate that. Let me copy this command, paste it here, because we know all the window function has the almost similar kind of next. This is not next, this is previous, and this is not lead, this is lag. Let me execute this command. We can see now we have received the result of lagging window function. We can see there is no one or no student before Myra. That is why previous student is null. While in front of Anya, you can see this is 86.5 and Myra's marks, which is before Anya. And likewise in front of Kabir, you can see this is now 72, because before Kabir we have a student. That is why in the lagging function you are getting the marks in against Kabir, but in the leading functions it was null. While in the leading function against Myra we had some values, because after Myra we have Anya. But in the lagging window function we can see Before Myra, there is no student actually exist. That is why that is null. So this is how you can use this lead and lag window function to get best of your data frame extraction result analytics and all. So today we completed all of this 5 window function: row number, rank, dense rank, which is basically used to assign some numerical value and some unique division ranking for the student based on their total percentage or their grading marks achieved. While lead and lag window function is used to get the next or the previous student marks to perform some arithmetic operation or perform some analytical operations on your data frame. So these all 5 window functions are very important for your interviews and whenever you are going to actually work with your data frame like this: price comparison, some student marks comparison. So these kind of data frames always require these window functions.